Hey guys, Mr. Gucci here, just making a quick sample video to help you with your thickness of foil lab. Now again, several students got a head start on this a couple days ago. Look to those people to help you out if you have some questions. But I'm also going to make a quick video to walk you through one sample set of calculations. All right, here we go. So what we got here first is one sample set of data. Okay, I just made this up, but it's pretty close to real. Okay, we took the first aluminum foil, I weighed it on the scale, and it was 0.23 grams. I took the width with a ruler, it was 13.1 centimeters, and I took the length with the ruler, 12.3 centimeters. Now, density. How do you get the density? Well, check this out. It is aluminum foil, meaning it's made of aluminum. If you know what a substance is, you can find its density online because it does not change. And I can just search density of aluminum in grams per cubic centimeter. That's a good unit to use right here. And it's 2.70. So in fact, I'm just going to copy this and I am going to paste it into the lab. In fact, what I can do is I can copy it and I can paste it in all three spots because it doesn't matter what the size of the aluminum foil is. It's aluminum. So its density is always the same. All right, so let's go down and look at the first problem here. So the first problem is to find the volume of the foil sample. Remember, you have to do this work on a separate sheet and submit it with the lab. This lab is due Friday, all right, so you don't need to submit it at the end of this class, but you will need to submit it soon. Okay, so first thing you got to do is find the foil volume, and to do that, you are going to use the density formula. Density equals mass divided by volume. And you're going to plug in what you know. You know the density of the foil because you looked it up online, and you know the mass of the foil because you used a scale. So what I would do here is I would, see here, still drawing, still working. Okay, so I would use density equals mass over volume. Okay, there's the formula. Next step, plug it in. The density is 2.70. The mass is, let me check, 0.23. All right, and we're trying to find the volume here. So how do we solve for a variable on the bottom of a fraction? Well, we multiply both sides by that variable. All right, it cancels out over here, and we have got volume times 2.70 equals 0.23. Remember, we're solving, we're trying to get the variable by itself. Here's the variable, all right? So it's being multiplied by 2.70. So we will divide by 2.70. Cancels out over here, and we'll do that over there. So the volume equals 0.23 divided by 2.70. So let me plug that in. Here we go. Just plug it into Google. 0.23 divided by 2.70. The volume of this sample here was 0.085. Okay, so I'm just going to plug that in. All right, the volume is 0.085 centimeters cubed. Okay, so that's the volume of this foil sample. All right, so on to the next problem. Calculate the thickness. Now, to calculate the thickness, you need to use the volume equals length times width times height formula. Okay, think about it. A sheet of foil, all right? You think of it as a flat two-dimensional sheet, but in actuality, it has a little tiny bit of height. It's very, 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 very thin height, all right? And what do we call a very, very thin height? That's just the thickness. So this foil has length, it has width, and it has height, which is the exact same thing as thickness. All right. So what are we going to do? We are going to use the volume equals length times width times height formula. Okay. We know what the volume is because we solved for it previously. The volume is 0.085. Okay. The volume was 0.085. 0.85 centimeters cubed. So we're going to plug that in here. The volume is 0.085 centimeters cubed. We also know the length and the width because they were part of the data that we recorded for this piece of foil. All right, the length was 12.3 and the width was 13.1. So 12.3 times 13.1 times the height. Now again, we're solving for the height here, which means undo what is being done to this variable. It's being multiplied by 13.1, so we'll divide by 13.1, all right? And if we do it over on this side, we got to do it on this side as well, 13.1. But the height is still being multiplied by 12.3. So to undo multiplying by 12.3, we'll divide by 12.3 to get rid of that, all right? So what we got here is the height of this foil. The thickness is 0.85 divided by 13.1 and then divided again by 12.3. So let's see here. 0.085 divided by, look at those numbers again, 13.1 and then divided again by 12.3. And we got 0.000527. 0.000527. So the answer is, let's hear, height is equal to 0.000527 centimeters. Okay, so let me just write that down here. It's equal to 0.000, what was that again? 527. 527 centimeters. All right, there we go. That's the thickness. Now, I will tell you right off the bat that this is totally wrong. Your answer is not going to be anything close to that. I have provided you the correct answers that you can use, okay? You can use the correct answers I gave you to judge where you are. And you're especially going to need them for this last part here, okay, in which you calculate your percent error. Now, I will tell you right now, the thickness of the first foil is 0.00160 centimeters. The thickness of the second was 0.00230 centimeters. And the thickness of the third foil, the thickest of the three, was 0.00990 centimeters. Okay, so let's find what my percent error is. All right, and to do that, we will use the percent error formula. The percent error formula is this. Percent error equals the actual value minus what you got, all right, and it has to be positive, divided by the actual value. Okay, so actual minus what you got divided by the actual. So the actual was, again, 0.006 centimeters minus 0.000527 centimeters, okay, divided by 0.0016. Make sure I'm still recording here. I am. Great. Okay, so let me just plug that into a calculator. It's going to be a little bit messy. Let me see here. So I'm going to do this part first. 0.0016 minus 0.000. Do this. Let's take a second. 1 second, folks. Okay, so that first part on top equals 0.00107. All right, so let me write this. So 0.00107 on top. Okay, always do the part on top first, and then divide by 0.0016. What do we get? All right, let's see here. 0.00107 divided by 0.0016. I get 0.669, okay? So my answer is 0.669. As a decimal, guys, bounce this once, bounce this twice. This is 66.9% error. That's bad. I did a bad job here, but that's fine because I was just guessing my numbers anyways, okay? The kind of errors that students have been getting so far have been 1% error, 2, 5%, maybe one person got 10% error. Guys, those are good numbers. That means you correctly measured the thickness of foil to within a fraction of the thickness of human hair. Okay, so hopefully this little walkthrough helps you guys figure this out. And again, consult with classmates who have completed this lab if you have any questions. All right, good luck, everyone.